The next book I want to talk about is Boscov-Copaziello, A Mathematical Journey to Relativity, Deriving Special and General Relativity with Basic Mathematics. So the concept of this book is really interesting because they see relativity as some kind of geometry, which it is, and they try to derive, so they try to see it as some kind of geometry, and then they kind of try to derive general relativity in the end from basic geometry. So the first part is Euclidean and non-Euclidean geometry, how they appear. Then they have basic effects in Euclidean and Minkowski plane geometry, geometrical inversion, cross ratio, projective geometry, and Poincaré disk model, surfaces in 3D space, basic differential geometry, some non-Euclidean geometries and their physical interpretation, gravity in Newtonian mechanics, special relativity, and finally general relativity and relativistic cosmology. So the book starts from the basics. It starts with basic Euclidean geometry and derives and gives the usual axioms, and then derives basically all you need from it. And then it goes on and talks more and more about geometry until in the end special relativity is entered. The concept of this book is really nice. But I think the book is quite lacking in terms that I don't think there are enough diagrams. I think the proofs are a bit too terse. I feel the book could be expanded a bit to make it more user-friendly. Maybe it is the reader's job to provide the diagrams and stuff. But yeah, I'm not sure I really agree with that. The book is very nice though, but I think there are maybe better books on the topic of mathematical relativity. Neighbor Special Relativity comes to mind as one. Still, if you're interested in the connection with relativity and the usual theory of geometry, I highly recommend it. Badescu and Carletti, Lectures on Geometry, is a book on geometry, and geometry as done with linear algebra, so it's analytic geometry. And it starts off with doing linear algebra, linear and quadratic forms, affine spaces, Euclidean spaces, affine hyperquadrics, projective spaces, Desargues axiom, general linear projective automorphism, affine geometry and projective geometry, projective hyperquadrics, Bezout's theorem of curves in P2K, absolute plane geometry, and Cayley-Klein geometries. Again, a book which ends with one of my favorite topics, Cayley-Klein geometries, which is why I bought it. I think the book is too terse and not really. I think the idea in the book is good, but I think they could spend more time making the book worth reading. I think it's maybe too rough at the edges right now, the way it is now. The concept is fine, but yeah, I wish it was a bit less rough around the edges. Next we come on a book of statistical mechanics, Introduction to Modern Statistical Mechanics by Chandler. And the book starts off with thermodynamics, conditions for equilibrium stability, statistical mechanics, non-interacting ideal systems, statistical mechanics, theory of phase transitions, Monte Carlo methods in statistical mechanics, classical fluids, and statistical mechanics for non-equilibrium situations. Yeah, pretty good book. Again, I think there are better books. I think Luscombe, for example, is a much better book on thermodynamics. Still, I think it's kind of a graduate level book. And if you, and I don't think there's anything in here that isn't in other books. So yeah. Next we have classical electromagnetism via relativity, an alternative approach to Maxwell's equation by Rosser. It starts off with a survey of the theory of special relativity. Electromagnetism is a second order effect. the electric and magnetic fields of a point charge moving with uniform velocity, Maxwell's equations of higher relativity, vector and scalar potential via relativity, relativistic electromagnetism. There are much better books on the topic. This book is way too terse. Ohanian comes to mind as a book that is much better with this topic and much more reader-friendly. Purcell is a much easier book. I mean, easy book. Purcell is not an easy book, but a much more readable book, I think, than this one. I think this is good for a graduate course, maybe, or if you're interested in perspective you haven't seen before. Here we come to Sachs and Wu, General Relativity for Mathematicians. Is a very mathematical introduction to relativity, where we have preliminaries, spacetimes, observers. Then we come to electromagnetism and matter, the Einstein field equations, photons, cosmology, further applications, and optional exercises on relativity and Newtonian. So yeah, very pure math book. Definitely should not be your first introduction to general relativity. I really hate the mathematical kind of introduction to special relativity. This is good if you already know what it is and want to see how it can be mathematically done rigorously, and maybe using a notation that mathematicians are more familiar with. Yeah, it's basically math with physics language. I think it's a good book. I think the book is definitely worth doing if you're into mathematics, and if you're into relativity, then I think it's a worthwhile book. If you just want to learn general relativity, even as a mathematician, I wouldn't. I mean, see here, like definition. Maxwell's equations become a definition. I mean, that's not something a physics book could ever do. It's a bit weird, but from a mathematical point of view, of course, it makes sense. Yeah, you can learn a lot from this book, but make sure you already know relativity and the differential geometry behind this. Next, we have a book by Ash, Information Theory. And it is a book on noiseless coding, discrete memoryless channel, error correcting codes, information sources, channels with memory, continuous channels. So this book is all about information and entropy and everything relating to that thing. It's very intuitive. It's a very intuitive explanation, which I really like. I do think there are probably much better books on the topic than this one. But intuition-wise, it's definitely worth doing. It's definitely a good side resource. I think my favorite book on this topic would be Cover and Thomas, but that's already very comprehensive and maybe starts off with some rigorous results that you might not care about in the beginning. Here we have a book, Introduction to Statistical Modeling of Extreme Values by Stuart Coles, which is a book on extreme value theory, which is again the subject developed in the Netherlands to see how high the floods were going to be. So yeah, I don't think I ever really read this book. I can't really say if it's any good or not. Next, we have a horrible book. It's Wakefield's Bayesian and Frequentist Regression Methods, which is all about regression and about different regression methods. So we have inferential approaches, we have frequentist inference, we have Bayesian inference, we have hypothesis testing and variable selection, we have linear models, general Bayesian model, regression models, binary data models, dependent data, non-parametric modeling. Why don't I like this book? Because I think it's too confusing. The math is there, but not explained really well. The intuition is not explained really well. It's mostly mathematical without intuition, and that means you already need to know the topic a great deal in order to get something of it. I had to work through this book for a class. I hated it, so yeah, not recommended. Next comes my favorite book on survival analysis, and it's by Klein and Muschberger. Techniques for censored and truncated data. Really beautiful book, really nice book for survival data, which is like, here we start with all kinds of very nice examples: bone marrow transplantation, time to death for breast cancer. So yeah, a lot of biological examples: time to first use marijuana, time to AIDS. Very good examples. Then basic quantities and models, censoring and truncation, non-parametric estimation of basic quantities for right censored and left truncated data, estimation of basic quantities on other sampling schemes, topics in univariate estimation. We come to hypothesis testing, semi-parametric proportional hazard regression with fixed covariates, refinement of the semi-parametric proportional hazards model, additive hazard regression models, regression diagnostics, inference for parametric regression models, multivariate survival statistics. I really like this book a lot. A lot of very nice, very beautiful information and examples, explained in a way that's really nice and intuitive. I really like this book. If you want to work with survival data, if you want to work with biological data or time until failure, even in engineering, like time until a lamp fails to burn anymore, I highly recommend this book. Very, very, very beautiful book. Then we have this book, which is Mathematical Statistics, a Decision Theory Approach by Ferguson, which is a book on statistics done mathematically. Decision theory approach is particularly nice in statistics because it means that you need to take a decision. Do I do I trust this casino with being fair, or do I not trust them? And it depends on you, of course. If you really need money, then you might trust the casino. If you don't really need money and just want to have some fun, maybe you trust the casino much less often. So this is the kind of thing that the book goes into. And yeah, I think it does it well, but yeah, it's a very mathematical book, of course. It's mathematical statistics, and it really deserves to be called mathematical statistics. You see here it uses topology, sigma field open sets, measure theory, everything here. So yeah, I'm not sure I really see the value of mathematical statistics. I think statistics should be done practically, in my opinion, and not mathematically. But if you're into mathematical statistics, this definitely is a worthwhile book to go to. Finally, we have here Using R for Introductory Statistics by Versani, which is again a Using R book, and which tells you how to do statistics. So it has univariate data, it has bivariate data, multivariate data, multivariate graphics, populations, statistical difference, confidence intervals, significance tests, goodness of fit, linear regression, analysis of variance, extension of the linear model. So basically, it's again, like all of these books, very little theory, mostly how to do it in R and how to use R to do these kind of things. If that's what you're interested in, let's say you want to fit a linear model and you're not sure how to look in this book, the book will definitely tell you. A very good book for that purpose. If you actually want to learn statistics, perhaps not so good for you. But yeah, this is the Using R series, of course.